In this video, we're going to look at the problem. A basketball has a mass of 0.625 kilograms and a radius of 11.43 centimeters. A basketball player balances the ball on his finger and applies a torque of 4 newton meters to the ball. What angular acceleration does the ball experience? Since I'm trying to relate torque and angular acceleration, I'm going to use the relationship torque net equals moment of inertia times angular acceleration. I then need to look up the moment of inertia equation for a hollow sphere, since a basketball is not solid inside. So I would look that up on the table of moment of inertia equations, and I find that it's 2/3 mass times radius squared. So I substitute that in for moment of inertia. So we now have torque equals 2/3 mr squared times the angular acceleration. So I'm going to plug in 4 newton meters for the torque. I'm going to plug in 0.265 kilograms. For the mass, I'm going to convert the 11.43 centimeters to meters by dividing by 100, so 0.1143 meters. And then I'm going to isolate the angular acceleration. So that gives me an angular acceleration of 735 radians per second squared.